Good evening, everybody. Welcome to the Big Things meetup today. I know the title was pretty intriguing about all of the sexy things. So we'll be presenting here Baruchi Har-Lev. He's from Tomobox. He'll be talking about machine learning and deep learning in the world of chats and notifying the sex solicitation chats. I'll leave him the stage and he will tell more about everything.
Great. So hi everyone. I'm the VP R&D at Tomobox. So before I start to talk a bit about myself, I've been dealing with language and speech processing for the last 10 years. I've been programming since I was 15. I'm an avid fan of machine learning, and in my spare time I teach DSP at Afeka College. So at Tomobox, what we do is we analyze messaging and we deliver insights in real time. And I want to share with you today something that we are doing, and that's preventing sex solicitation posts in public chat rooms. Now, I've decided to name my talk 3 things to know about machine learning and sex solicitation, but you can see at the bottom the way you would most commonly find it in chat rooms. Messaging, as you know, is very convoluted. We talk in multiple languages, in typos, intentional typos, abbreviations. Our language changes all the time. Now, I'll ask you, for you, what is LOL, for example? Great, for me it's League of Legends. I like to play games. So you know, we don't have to have the same abbreviations or anything. So first of all, let's understand where are we at. So we're in a public chat room where you can see the messages flow on the right. It can be any chat room that you want. It can be, let's say, a famous singer chat room. It can be a gaming chat room. It can be a dating app or whatever you can think about. And what we want to do is make this environment safer. I'll go back there. So basically, let's see some example now. I'm preparing you in advance. They won't be nice example. You see a lot of profanities in this talk. I am sorry for that. But it can come in nice English, well, not so nice, but you know, the language, to some typos, a lot of typos, a lot of abbreviations. Obviously, I'm not, you can see that, and it can also come in many languages. So we want to prevent all of this. We want to have one unifying system that would prevent this from appearing in your chat. And you can think about, your children chatting up, and you don't want them to see that. So what we require to filter out the solicitation post. We want to do it in real time. We want to support multiple languages, and we want to be sensitive to lingo changes because, especially in the text area, I've been dealing with text for 10 years with language. Language is a living organism. It changes all the time, and in text it changes very frequently. Every month you'll see new abbreviation, new ways of saying things, new ways of saying these things. So first of all, I want to show you a small demo that I prepared. So we'll just let it run. So on the right, on the left, you can see that, and this is actually live. It's from one of our partners. You can see the posts that are running, and whenever you see a post in red, it will also go to the right side, and we'll say, okay, well, this is a solicitation post. This is what we want to prevent. Keep in mind that this is a probability game. We use unsupervised machine learning to do that. Okay? Great. So let's go back to the talk.
Where are the posts from? What did we see?
One of our partners has a public chat room, and this is actually his data. I'm not going to mention the name. Sorry. So again, the goal is to prevent sex solicitation. So I want to take you today to a journey to where we started at and where we finished, and why have we chosen unsupervised machine learning to actually solve this system. So I'm going to ask you first of all, what would you do? Do you have any suggestions?
Spam filters.
Sorry?
Spam filters.
Spam filters. That's a very good suggestion. Any other suggestions?
Parental supervision.
Parental supervision. Okay, that requires something else. That requires somebody to view it. I want to make it an automatic system. But it's not a bad idea. So let's see where we started at. So I'm saying to myself, well, I'm an accomplished software engineer. I know keyword search. I know how to create a regex. I even made Lucene work for me once, and not me for Lucene. So of course I'm going to do a keyword search, and the first thing I'm going to create is a lexicon, and my lexicon will probably have all the words that you expect, fuck, sex, and so on, all the words that we do not want to see. So obviously I created a lexicon, and now what I need to do is I need to create some heuristic rules saying, well, if the sentence has 10 words and 2 words out of it are one of the lexicon, then say, well, hey, here's a solicitation post. The problem, I can say, well, this is fucking fuck, this doesn't work. And obviously this is not sex solicitation. So I have a problem. And then I'm saying, well, if this doesn't work, I know, I'll add types. So now I have types. Let's say profanity words, abusive words, words that can indicate sex solicitation. And obviously I added more things, I need to add more heuristic rules. And when I try this out, this also doesn't work. So I'm saying, well, I know, we need to weight everything. And once we weight everything, we need to sum it up, and we need to normalize, and of course we need to add even more heuristic rules. What?
You need a semantic analyzer.
We'll get to that. So,
To get the word and its content.
yep, to get the content. So by this point, 2 things have happened. The first thing is, I can no longer understand my system. I can no longer track and say what happened there. You can actually take a PhD doctor just on this system alone. The second thing is that by now the lingo has changed, which makes me want to go back to the lexicon and revise it. So while keyword search is a very efficient tool, it is not efficient for what I need to prevent sex solicitation posts. It is very good if in closed domain. If you have a set of words that doesn't change and you want to use it, this is probably your safest bet. But for what we need, this doesn't work. So we're asking again, okay, what do we do now? And remember, this is the process we passed through. So obviously we said, okay, let's do semantics. So we're going to parsing. Now, I've used a parser once or twice in my life. Parsers are a great tool. It lets you to better understand the context. I'm basically taking a sentence and I'm saying, who's the noun, who's the verb, who's connecting to who, and how. Organization, just a shallow parser. So let's see a simple example, and I'm going to take a very, very simple sentence. Mary sees Jack. Everybody understands this sentence, right? Very simple one. So let's see how the parsing tree looks in here. So this is the parsing tree. So it's a bit complicated, the parsing tree. And if you don't understand it like this, we'll put it in a table. Well, it's still complicated. The problem with parsers is you need a very good understanding on what you do with them. And on top of that, you also need to add heuristic rules to say, well, if I found the noun, and the noun is related with an adjective or some verb, then say, I'm going back to the same problem I had before.
It's also limited to the sentences with proper grammar.
Right, very good. So parsers are trained usually statistically and for one language. Now remember, I want to be language agnostic. I want to handle multiple languages at the same time. So parsers do not help me in this case. It is very good if you want to do entity extraction in a certain language. If I want to search for something in baseball or sports or something like this, I would probably take parsers. But for the job of preventing sex solicitation in a public chat room, well, this doesn't work. So we went back to the drawing board and we asked again, okay, what do we do? And the answer, of course, was machine learning. So we're going to talk a bit about machine learning, and we're going to start with general understanding of machine learning. So in machine learning, we take our data and we say, okay, I have a set of data. I'm now going to extract features from it. Features can be words, it can be energy of signal, it can be whatever you want it to be, the data that represent your features that represent your data. And then I'm saying, okay, I'll train the system, and by the time I'm done training, hopefully if I've done everything right, I have a valid statistical model that answers a problem that I have, some challenge that I want. So usually when we train with supervised or unsupervised method. But let's just understand what's the feature extraction. I'm going to take a simple feature extraction, features that we use as one of the features that we use in the system, and that's a bag of words. Now, a bag of words is a very simple model. Basically, you can see the sentence here, come see my penis, come see, it's very easy. Basically, all we do is we count the word and we say, this is the number of times I say this word, and I'm getting this table. The word come is first in the lexicon, or second, to be more exact, and I've seen it twice. And I'm getting just a vector of numbers. The important thing to understand about bag of words is orderless. It doesn't maintain the order of the sentence. So if I would want to use an algorithm later on that the order is important, I cannot use this. But that's just an example to what you do when you extract features. Great, so I have my features ready now. I want to train my system. So obviously the first thing we did is we said, okay, let's look. Now I know I promised you no formulas or function, but I had to take one. And this is a very important function. So for those of you who remember statistics, this is base rule. And I like to look at it more like this. I'm saying the posterior is equal to the likelihood times the prior divided by the evidence. And the wording is not just any random wording. It's very important. When we're saying the likelihood, so in here, X is my data, theta is my model. When I'm saying the likelihood, I'm basically measuring the probability that my data fits my model. How good is my data to my model? When I'm calculating the prior, I'm saying, listen, I have some understanding of how my data is going to work. I'm saying it's going to distribute normal, it's going to distribute Riley, some sort of distribution. Probably the hardest thing to calculate in this entire formula is the evidence. Because the evidence requires us to calculate the law of entire probability, and it's usually an intractable problem. So in machine learning, what you do is, when you say supervised learning, you say, well, I don't care about the evidence, I'm going to just use the likelihood, and sometimes I'm going to use the prior. Why? Because it's easy. So this is how we train SVM and sometimes neural network, recurrent neural networks. But what we do in supervised machine learning is basically we're saying, we're taking our data and we're starting to tag it manually, saying, well, this post is solicitation, this post is not solicitation, this is solicitation, not solicitation, and so on. And I'm fitting it to the system. And the system will probably create for me a very good classifier that will tell me if this post is soliciting or not. The problem with it is that after a month, I will probably need to retrain the system. And that's, again, manual work. So supervised algorithm, we used SVM, which was initially worked really well, but after a month, it really crashed. So it's good for slow changing environments. In a public chat room, the language changes very quickly. It's not really good for us. So at this point, we said, okay, we need to go somewhere. Where do we want to go? And we said, well, we want to go to unsupervised machine learning. Now, of course, we need to calculate the evidence, and there are many algorithms that helps us do it. But basically, here's the thing to understand about unsupervised machine learning. So unsupervised machine learning is a generative model. It's a generative Bayesian model, well, some of the models that we use. And here's the difference. So if I'm saying in supervised learning, I'm saying to the system, well, listen, this is a mouse, this is a phone. This is a mouse, this is a phone, a mouse, a phone. At some point when I'll come to the system, I'll say, well, what is this? It will say, this is a phone. What is this? This is a mouse. So the system will be good, but what happens if I'll show the system this?
It's a phone.
It's a phone, right. The system will probably tell me it's a phone because this is what the system knows. In unsupervised machine learning, we're doing something completely different. We're saying to the system, listen, here's my table, here's my room. Please break it apart and rebuild it for me. And while the system rebuilds the room back, I'm pulling from underneath things that the system deemed worthy, that have the same context. So it will tell me, listen, this is something, and I'll say, oh, hey, this is a phone, this is a mouse, this is a notebook. So basically what we're doing is we're clustering the data. And in the end, we generate clusters of words, and you can see in here a cluster of abusive words that the system chose. I did not choose these words. and the system chose it out of a public chat room. This is one of the contexts that it created. So unsupervised machine learning really answers the problem of handling multiple languages, handling lingo changes, because it's not really hard to train an unsupervised machine learning algorithm. And you can use several of them. So what we do is we use 3 models at the same time. A model of how we talked last week, how we talked last month, and an online changing model that changes all the time on the fly, saying, okay, what is important now? So this is what we do. So I won't keep it long. So let's conclude. So for the job of sex solicitation in public chat room, we've seen keyword search, which is very good for closed domain. It's not good for us. We've seen parsing, which is great for entity extraction, but again, not good for public chat room. And we've seen supervised language, which is very good for spam detection, as we said, or other methods. But for this job, for this fast-changing environment, it really doesn't work. If we want to include both real-time, multiple languages, and fast-pacing lingo changes, we need to go to unsupervised machine learning. Great. So this is basically what I wanted to say. Now, before I finish my talk, I want to give you an opportunity. I want to present an opportunity. So if you feel that data analysis and machine learning is really in your blood, and you wake up every morning and you say, well, yay, I want to meet you. We're now growing. I really want to meet you. The second thing is we will be opening our API for a limited amount of time, and I would really like you to try it out if you feel you're up for it. It's a simple REST API. It will work on solicitation post, true or false. So please email me. I'll give you all the details, and feel free to play with it. Thank you.
About your technology stack, what you're actually using for all of these things, like what's your backend and how are you making all of the machine learning and everything in the back of everything? So
everything is in the cloud. The next phase we're moving into is actually moving the system into Spark, because we're growing data. Today we're analyzing about 1 million posts a day in this system, and it's only growing with more customers that are coming. But we have a lot of data from other sources that is coming. We want to move it to Spark. Today it's working really relatively just the same. We're training on 2 machines, not more than that. The training doesn't take that long, but we want to make it bigger, faster algorithms. But for today, it works on Tomcat, a REST service. By the way, the system itself works really fast. It's less than 1 millisecond to give a decision, not only in the sex solicitation part.
And the training part, how much is it?
I'm sorry?
The training part?
The training, it depends on how many training. The online training takes nothing because it happens all the time on the fly. The 1 week takes about 40 minutes. The 1 month takes about 2 hours to train. Really depends. Yeah.
Have you considered attacks on the system?
I'm sorry?
Have you considered attacks on the system?
Attacks on the system?
Can you repeat the
If I
question?
feed the text, I will actually change the behavior of your data classifier, for example.
Well, it is
And then I will
unsupervised.
forget about the solicitation basically and will work on my term.
I'm not sure I follow the question. Maybe you
For
can
example,
rephrase.
you have take your example of basic words.
Uh-huh.
For frequently used words, if I use
Everyone.
different words, you will
Yeah, of course.
change the language.
Of course, it's a language change. But it will.
Artificial language.
We actually never worked on artificial text. We were lucky enough to get from day one real live data.
I'm sure that you consider our sources are feeding your language.
Of course, we have a system that can operate with several algorithms together, aggregate them. It's not that we're using one algorithm and just this. It's a bit more complicated than that, but it's very cool. I would like, if you want, one-on-one, I'll explain it definitely. Yeah.
I was wondering, for clustering, you need to define a certain distance function to measure, to give a, you have two words,
So-
you need to have something that gives out the distance between them.
It's a
How
good
can you do
question.
that between two words?
So we're not doing it between two words. Remember, the system does not understand language, it understands context. And we use a couple of algorithms, and in several of them, we say to the system, I want 100 clusters, and in several of them, we say to the system, give us the amount of clusters you want. So it will give us 140, 80, or whatever. We're not using regular distance measure between clusters. I'm not doing, for example, k-means. I'm not saying find k clusters and then calculate the distance between this point and this center and say, okay, am I closer to this or to this? It's a different game.
But you still need to parse the sentence. So you back to the standard process.
I
and
don't-
back to natural language parsing problem.
No, today I'm not parsing the sentence. I'm feeding it to the system as it is.
And how do you feature exceptions on the proposal?
So one of the features we're using is better words. We're using also other features.
The feature engineering is also there with part.
Well, I agree. It is. I'm not going to elaborate on our features now, but we are using different features as well. Think about the way we talk. There's a lot of noise. The question is how you handle the noise.
You use embedding?
Sorry?
Embedding? Word embedding?
No. No.
Have you tried carrot?
I can't hear you.
Have you tried carrot?
Carrot?
Yes,
I'm not sure I'm familiar with carrot.
the clustering.
No, I would be happy to hear about it.
How do you validate your model?
Oh, good question. How do you validate your model? So actually for the sex solicitation model, we took an external company with one of our partners and we asked them to tag for us solicitation post. And we checked it. We have, we've done the confusion matrix, we know the accuracy of the system, the recall precision, and so on.
But that's a one-time, so how do you continuously validate?
We do it
How
every
you
couple of
A/B?
months. You have to.
So you don't have like a mechanism to A/B test algorithms online? Or?
So we have to, it's a different thing when you actually create the algorithm, you check if it works, then you take it into a system, then you take it into real time, then scaling. Obviously, you need to recheck your
You need
model.
an online metric.
Today, we get from our partners, we get the result.
Right.
We get very
That's
good.
like a feedback.
We get very good feedback on what we do.
Feedback.
Great talking to you. Yeah.